Hello and welcome back. We're excited to get back started with Jason here. You want to say hi, introduce yourself?
Hey, everybody. I introduced myself in the talk at the very beginning, but I
Great.
just wanted to let everyone know that I'm here, available for questions on the Slack channel. I wanted to pre-record it because I've got a lot of kids. It's chaos. It's the middle of the lunch break for school for them. But yeah, if you have any questions, feel free to ask me. And I didn't mention it in the talk, but I'm on Twitter. I'll share the Twitter link in the Slack channel.
Perfect. Thanks. All right. And with that, let's get started.
Welcome to Embedding Flutter in your app for fun and profit. My name is Jason Mayer. Just a quick intro. I'm a senior software engineer on the games team at the New York Times. I've been on the team for nearly 5 years, and in that time, we've been building fun products like the crossword, Spelling Bee, Letterboxd, which is the brainchild of Ben Obergfell from yesterday's Compose talk, Tiles, and more than a dozen other games that we've prototyped and put on the website. I've worked on video games, I've published a board game, and most of my free time these days is spent playing Minecraft with my 3 kids. So how did I get started with Flutter? Every year at the Times, we have a week called Maker Week where we can drop whatever we're doing, skip out on meetings, and do something fun. In 2016, the New York Times didn't have a crossword Android app, so that's what I spent my time on. 2017, we actually added real-time multiplayer to the crossword, which we never released, but we learned a lot from that process. And in 2018, I spent my Maker Week learning Flutter, and I built the first Spelling Bee prototype. So, what exactly is Spelling Bee? It's actually really great. It's a game like Othello. It's super easy to learn and difficult to master. My 6-year-old can play it. But you make words that use any of the letters, but you have to use the middle letter, and the word that you create has to be 4 letters long or longer. It's curated every day by Sam Mazursky, and it's very difficult. You'll rarely see any S's or common letter patterns like ER show up. And fun fact, only 1% of our users regularly find all the words and achieve the coveted queen bee status. If you use all the 7 letters, you found one of our pangrams for the day, and you get some bonus points. Eventually, we took the time to productionalize my Maker Week experiment, and today you can see the finished product in our crossword apps on iOS and on Android. Note that I am not now, nor have I ever been an iOS developer, but with Flutter, I was able to fake it. In this talk, I'm going to show you how to add a Flutter module to your existing Android app. However, before we get started, in the words of Jeannie, there's a couple of provisos, a couple of quid pro quos. Your Android app can't support MIPS or 32-bit architecture. Flutter currently only supports building ahead of time using compiled libraries for x86 64. Also, as of 1.17, the Flutter module only supports Android X applications. If you haven't migrated to Android X yet, you should totally do so. There's also some danger. Your app can crash. We didn't realize this when we first launched to our closed alpha, but somebody installed the app on an old x86 32 Chromebook, and it would see the other x86 libraries like RenderScript and then blow up when it couldn't find the libflutter.so file. So you need to add this to your build Gradle in order to actually make that work for everything. You also need to have a Flutter project. We're going to assume that you've already built a Flutter project and you want to include that in your app. We're not going to spend any time talking about the Dart or the Flutter side of things. This is mostly about how to integrate with your existing Android app. If you don't have one, you can just generate one with Android Studio like so. And if you're like me and you just breeze through the wizard setup, you can actually change in your Flutter code, and there's a pubspec.yaml, you can change your Android package, which is how we're going to reference it when we go to setting up this in the AAR. All right, so with that stuff out of the way, One last thing that you're going to want to make sure that you've done. If you're just setting up a new project, you're going to want to at least run it once so that it can do the Gradle magic and download everything, create the generated files that we're going to reference, and let's get into it. So the first thing that we're going to do is we're going to add the dependencies. The Flutter team has been very busy making improvements for the last year, and all of these steps are actually way easier than they were at this time last year. My talk actually trimmed out more than I added. So there's two different ways to go about adding Flutter to your app. The first way, we're going to depend on the AAR files as a library in the standard Android way. And the second way is to depend on your source code directly. Most people I've spoken with use the source code for development. The number two approach is way faster for development, way easier. We've actually taken kind of a hybrid approach where our releases are built using the first step there. But the second part is the way that we do almost all of our development. So how do you go about doing this? In your Flutter app, Flutter has a built-in command to build an AAR with a build number, and it creates a local Maven repo. Now for us, what we do is we actually tar up the contents of that build host outputs directory, and we tar that up and we deploy it to an internal Maven repo. We do all of our builds with Bitrise, and so that bug fix number on the end there is actually the CI build number. I think that's probably pretty standard. The second way to go about doing this is to actually, the second thing that you need to do is to add the dependencies to your build.gradle. So when you actually run the build AAR command, part of the output is to tell you exactly what you need to put into your code. And this is that output there. One of the benefits of this approach is that people who build your app don't need to have the Flutter SDK installed. So that's really helpful. Now, the second way to go about doing things is to depend on the source. The alternate way to go about all this is just to depend on the source. You basically add your reference to your project in the dependency section of your build.gradle. And I don't know this for sure, but I've heard that this is part of the reason why only one Flutter module at a time is supported in an app. I'm not entirely sure about that though. So the next thing that you need to do is modify your settings.gradle. And earlier I said that one of the things that you need to do is run your Flutter module for the first time. That generates an Android directory, a .android directory that has this include Flutter.groovy script that does a bit of the Gradle magic and adds the embedding dependencies for you. So that's actually the hard stuff. So we need to move on to the next step, which is just to update the manifest. You'll want to add this to your manifest. This is slightly abbreviated. You can grab the full config changes from the Flutter docs at the link on the slide. Also, shout out to the Google team for their work on the docs. They put in a lot of work to update the documentation this year and migrating from the old Flutter wiki on GitHub. And it shows. This documentation is really great. So what else do we need to do to get started? Well, now we need to actually launch the Flutter activity, and we're almost done. Okay, so when you make a new Android project, I'm sure you're all familiar with this. There's like an activity main, there's like a small fragment with a next button, and then a floating action button. Now, what I'm going to do is just hijack that click listener on the floating action button, and we're going to launch Flutter activity.create default intent. And what that's going to do is take us right into the Flutter activity. Let's take a look at what we get for our efforts. So the first click here, I recorded this using QuickTime, and I added the mouse click so that you can see exactly when I click on the button. The first click that you'll see here is giving the emulator focus, and the second one is when I actually launch the new window. Let me play that one more time. The first one grabs a window. The second one actually starts the click event. So did you catch that delay? Now, there's almost a 2-second delay um, of startup. So that's because there's a noticeable performance hit as the Flutter engine is starting up for the first time. We have to do a lot of things. We have to create the VM. We have to load the fonts, assets. We have to execute the main entry point. We have to create the widget tree, which is part of what Flutter does on, and then we have to compile the shaders. There's a lot of stuff that has to go on, and it takes time. Now, the docs are pretty old on the Flutter doc site for these benchmarks, but this is what it actually gives you in terms of the time that it takes for Flutter version 1.10. We're currently on version 1.20, so Flutter team, if you're out there, it would be really nice to have some updated numbers here. There have been significant improvements in terms of the API, but you can still see the delay here, but there has to be something that we can do to make it better. Well, a wise coworker once told me that in computer science, no problem is too big that it can't be improved by sprinkling a little bit of caching on it. So that's what we're going to do. The Flutter team has basically pushed the optimizations to the limit. And what we need to do is actually cache our Flutter engine during application startup in order to make everything seem a lot smoother. Now, this is an optimization that's kind of a little bit smoke and mirrors, but basically what we're trying to do is make it so that it's not a visible delay to our users, because that's what really counts. So the way that we go about doing that is relatively straightforward. And in fact, for this slide, I ended up taking out a lot more than putting in. So looking back at my code from February, there's a lot of improvements and streamlining of here. Like there used to be hoops that you have to go through, like starting your Flutter initialization, making sure that it finished, registering your plugins, that sort of thing. That's all actually been moved into the Flutter constructor. And so if you've got that in your code from a while back, if you upgrade your Flutter engine, if you upgrade your Flutter version, you can actually get rid of that code and go with the new stuff. All right, so what do we got here? So we instantiate our Flutter engine, and then we start executing a Dart entry point. Now, that Dart entry point.create default method is actually creating a reference to the main function in your Dart code. If you've overridden that code or changed the way that your app is instantiated within that Flutter code, you can change that here. I do want to stress, though, that at this point, you are using up resources. Like the CPU overhead that we talked about on the previous slide has been pushed to your application module or your application class. But it's important to know that you're also using up RAM for spinning up your engine. There's about a 40 megabyte RAM overhead for starting up a Flutter engine. And every time that you create a new Flutter engine, that is going to be the case. So you need to make sure that you're clearing out those things or killing off those engines if you no longer need them. Once you've got your Flutter engine and it's ready to go, you throw it into the Flutter engine cache. And this is actually just a straight up hash map. This is going to go into your. This is a map of string to Flutter engine objects, and this is just stored in memory, so you can reference that at a later point when we start up our activity. So how do we actually use that Flutter cached engine that we've created? Well, it's really, again, it's very simple. We just change it from Flutter activity to Flutter activity with cached engine, and we pass it that engine ID. What that does is it tells that Flutter activity to use a specific engine out of the engine cache, and you get a huge impact in terms of responsiveness of your engine starting. So let's take a look at what that looks like. The one on the right has the same blue outline from when I clicked gain focus and then when I click the button, and it immediately starts up the Flutter demo homepage. The one on the left, of course, you can still see that white splash screen as it starts to load and start up the engine. This is clearly a huge improvement. For whatever reason, you might need to extend the Flutter activity. Like, say, for instance, you're injecting something via Dagger or just whatever else. There's any number of reasons why you might need to do this. So I'm including this for completeness. Basically, all you need to do is add a static method that returns a cached engine intent builder to your class, in your class that extends Flutter activity. And you pass that cached engine intent builder with a reference to your Flutter activity class. And then you also pass in the engine ID that you're going to be referencing. Then when you're trying to click on your floating action button, you just say embedded Flutter activity with cached engine. Now, of course, you'll also need to add that to your manifest, but that's pretty much it. Now, what is a method channel? A method channel is the way that your Flutter module talks to your hosting app and vice versa. So say you've got like a Kotlin or Java object that gives you user data, or you have an email support helper class that you've already written, and you simply want to reuse that logic from your Flutter code. That's really the entire point of adding Flutter to your existing Android app anyway. If you've got a complicated e-commerce class that handles everything perfectly already, you really don't want to rewrite that in Flutter or in Dart. So this is the way that you would set up that method channel, a method call handler. By binding to a method channel on a specific channel, this is just a string, and then responding to it. And let's take a look at what that might look like. Every on-method call is given a call and a result object. The call.method is actually just a string that's a reference to whatever it is that you're trying to do. And then the call.arguments is another string that is passed to it, although there's other codecs as well, so that you can pass ints or whatever. The Java docs actually called it the arguments class a map or a JSON object. It's actually technically just an object. And so we actually decided to use a JSON object, a JSON string, as our means of transferring data across. And so, we're already using JSON, so we just, threw that across the wire and, easy peasy, we're lemon squeezy, we're all done. So it's an easy lift for us. You can argue that this can lead to situations where your Flutter code is passing an object that doesn't parse correctly to your Android code and vice versa, and you'd be right, but this worked out pretty well for us during development. So when might you need to do this in an activity? Well, like say you wanted to show a toast or inflate a view or whatever your specific needs are that require an activity or context that's not an application context. You can do it in the activity in basically the same way. So, we're binding to that method channel in our new activity class that extends from Flutter activity, and we're basically just doing the same thing. Now, we're personally at the New York Times using the JSON objects, but there's other options. I recently learned about this library called Pigeon, and it looks really interesting. There's also, protobufs that I looked into using to pass data back and forth, but I hit my time box window and I called that one a day. If you experiment with protobufs or with this new Pigeon library, and you find that it's way easier to use, let me know on Twitter. I'd really love to use this. Type safety is really attractive to me. And I did my original research a long time ago, and things might have changed on the protobuf side. So to recap, what did we do? We added a Flutter module to our app. We cached that engine so we could improve the user experience. We talked to the hosting app, and then we reused our existing Android code. And we learned how to extend the Flutter activity, and we talked about a couple of reasons why we might want to do that. If you're interested in more Flutter, the best place to go is the docs. They are the source of truth. Also, I would highly recommend checking out Matt Carroll's talk from last year's DroidCon New York City, where he talked about some of the details about Flutter activity versus Flutter fragment versus Flutter view. And also, he has a new venture with lots of tutorials at superdeclarative.com. The community in Flutter is extremely great, and they're super helpful. Discord channel is great. I would totally recommend it. They're super informative and helpful. 1010 would rely on again. And finally, check out the Boring Flutter Development Show on YouTube. There's lots of great content on there as well. And I think that's about it. Thanks. I would love to work with you. We're always hiring. Apply on our website. Let's build some fun stuff together. And if there's any questions that you have that I didn't answer, let me know in the Slack channel and I'll try to get to it. Thank you very much.
Amazing. Thank you so much, Jason. And with that, if you have any questions about anything that he talked about, you can head over to Slack, go to the Day 2 Jason Meyer channel. We'll be doing questions asynchronously there. So feel free to pop in, do that. We have about 9 minutes till the next talk. Feel free to visit the expo. You can also investigate the networking feature in Hopin if you want to meet some new people while you're here. All right. Thanks so much, and we'll see you in a couple minutes.